Nobody told you that the real competition for your job might not come from someone in another country. It might not come from a younger worker willing to accept lower pay. The next competitor in the American labor market might not need a paycheck at all. For most of modern history, work followed a simple contract. You showed up, you gave your time and skill, and in return you received income, security, and something that felt like stability. That contract held through wars, recessions, and technological upheaval. Factories changed. Offices changed. Entire industries transformed. But the fundamental exchange between human labor and economic reward remained more or less intact. What Tesla is doing right now may be the most serious challenge to that contract in the last 100 years. And the story has almost nothing to do with robots. Before we go any further, understand something. This video is not about engineering. It is not about artificial intelligence features or how many fingers a machine can move per second. Those details matter to engineers. What matters to everyone else is a much older and more uncomfortable question. What happens to work when the price of labor drops to nearly zero? Think about what happened to American farming in the early 20th century. In 1900, roughly 40% of the American workforce was employed in agriculture. Feeding the country required millions of human hands. Then came the tractor, and later the combine harvester, and then mechanized irrigation. And within 2 generations, the agricultural workforce shrank to under 2% of the total labor force. Millions of farming jobs vanished. But something else happened too. Food became extraordinarily cheap. The productivity explosion generated by mechanized agriculture freed up tens of millions of workers to move into factories, offices, and service industries. The economy did not collapse. It transformed. The question worth asking today is whether we are standing at the beginning of a transformation on that same scale, or possibly larger. Tesla announced in late 2025 that its Optimus robot had entered pilot production at the Fremont factory in California. By late 2026, the company is targeting 1 million units produced annually. By 2027, a new dedicated facility in Texas is being designed for a production capacity of 10 million units per year. 10 million. To put that number in perspective, the entire United States manufactures roughly 10 million automobiles per year. Tesla is describing a production ambition for robots that matches the entire annual output of the American car industry. That number is either one of the most audacious manufacturing claims ever made, or it is the opening act of something that genuinely reshapes the structure of the American workforce. There is very little middle ground. Elon Musk made a statement recently that deserves more attention than it received. He said, and the phrasing matters here, that the foundation of the economy is labor, and that capital equipment is distilled labor. If you have distilled labor, you do not actually have a labor shortage. On the surface, that sounds like a Silicon Valley talking point. But follow the logic carefully. What Musk is describing is not a robot that competes with workers. He is describing a machine that functions as a form of stored, deployable, infinitely scalable human effort. Not automation in the traditional industrial sense. Something structurally different. And the reason that distinction matters is because the United States is currently experiencing a labor shortage that is not going away on its own. Here is a fact that does not get nearly enough coverage in mainstream media. 25% of the current American manufacturing workforce is 55 years of age or older. These are experienced machinists, line operators, quality control specialists, people who carry decades of technical knowledge in their heads. Over the next 10 years, millions of them will retire. Industry analysts project that approximately 2.11 million manufacturing positions could go unfilled between 2025 and 2030. Not because workers refuse to apply, but because there simply are not enough younger workers entering these trades to replace the people who are leaving. This is not a political problem. It is a demographic one, and demographic problems do not respond to policy speeches. The situation in warehousing and logistics is equally stark. Despite a national unemployment rate of roughly 4%, there are currently an estimated 7 million unfilled jobs in the transportation and logistics sector in the United States alone. 76% of employers in that sector report ongoing difficulty filling roles. 63% of freight businesses say that driver recruitment has stagnated or worsened over the last 2 years. These are not fringe statistics. These are structural signals of an economy where the supply of available workers is beginning to fall behind the demand for their labor. And that gap is going to widen as the baby boom generation continues its exit from the workforce. This is the context that Elon Musk is building Optimus inside of. Not a science fiction fantasy about robot servants. A calculated industrial response to a demographic crisis that no politician wants to talk about plainly. Morgan Stanley, the investment bank, made this point explicitly in recent analysis, writing that as the working-age population in advanced economies continues to decline, humanoid robots may prove to be a requirement, not a luxury, for industries already facing difficulty attracting enough workers. A requirement. That framing should stop you cold, because it means that for certain sectors of the American economy, the question may not be whether robots replace human workers. The question may be whether robots prevent entire industries from collapsing. Now here is where the story gets complicated and where honest analysis requires looking at both sides of the ledger. Morgan Stanley's financial projections, which are among the more carefully sourced in the industry, estimate that a humanoid robot operating at scale could cost a business approximately $5 per hour to operate, compared to roughly $50 per hour when you factor in the full cost of a human worker, including wages, benefits, insurance, payroll taxes, and turnover. Over a 20-year period, that differential translates to between $500,000 and $1 million in savings per worker position. Multiply that by the scale of production Tesla is targeting, and you are looking at a potential economic restructuring of American industry that dwarfs anything the last 30 years of automation produced. Goldman Sachs analysts have described humanoid robots as the artificial intelligence accelerant, the moment when AI stops living in software and begins operating in the physical world. But here is where the counter-argument must be taken seriously, because anyone presenting you with only the bull case is selling something. Rodney Brooks is not a casual observer. He is a co-founder of iRobot and a former director of the MIT Computer Science and Artificial Intelligence Laboratory. He has spent decades closer to the technical reality of robotics than almost anyone alive. His assessment of current humanoid robot capabilities is not optimistic. He points out that the human hand contains approximately 17,000 tactile receptors, providing the kind of fine sensory feedback that allows a person to thread a needle, feel the difference between a loose bolt and a stripped one, or handle a cracked egg without breaking it. Today's humanoid robots have essentially zero tactile sensing at that level of sophistication. The infrastructure for high-fidelity touch data does not yet exist in the way that image data existed when computer vision began its rapid improvement. Brooks calls the idea of video-based learning producing human-level hand dexterity in the near term what he describes as pure fantasy thinking. Beyond dexterity, there are hard economic and logistical obstacles that Tesla's promotional videos do not address. Current humanoid robots from various manufacturers are priced between $120,000 and $200,000 per unit. Tesla's stated target price is $20,000 to $30,000. That gap is not a rounding error. It is a fundamental manufacturing and cost reduction challenge that may take years longer than projected timelines suggest. Established industrial automation, including collaborative robotic arms and autonomous mobile platforms, already operates at 95% or better uptime with 20 or more hours of daily operation and has decades of maintenance infrastructure supporting it. No humanoid robot in production today matches that standard. The moment a 60-kilogram machine moving at speed through a shared human workspace fails unexpectedly, the liability and safety questions become immediate, serious, and potentially industry-defining in the wrong direction. And then there is the regulatory environment. The United States does not currently have established safety standards for bipedal humanoid robots operating in shared workplaces alongside human beings. Building those standards takes time. Industry adoption at scale requires insurance frameworks, legal clarity, and social acceptance, none of which arrive simply because a product is technically impressive. The history of autonomous vehicles should serve as a reference point. The technology has been demonstrably capable of basic operation for years. The path from demonstration to widespread deployment has proven far longer and far more complicated than early projections suggested. So where does that leave the American worker? Specifically the worker who is watching this video, because this topic hits close to home. The honest answer, supported by research rather than optimism or fear, is that history suggests transformation rather than elimination. MIT economists studying industrial automation have found repeatedly that automation tends to eliminate specific tasks within jobs rather than eliminating jobs entirely. When assembly lines arrived, workers did not disappear from factories. Their roles changed. When computers entered offices in the 1980s and 90s, administrative jobs transformed rather than vanished. The economy repeatedly demonstrated an ability to generate new categories of work as old tasks became mechanized. The concern that economists raise today is subtler and, for many workers, more troubling than simple job elimination. The worry is that this round of automation may transform jobs faster than workers can retrain for new ones, and that the benefits of productivity gains may concentrate among capital owners and highly skilled workers while lower income and lower skilled workers face displacement into worse economic circumstances. The IMF has estimated that artificial intelligence and robotics could affect 40% of global employment with deeply uneven impacts across skill levels. The World Bank has noted that productivity gains in automation historically create new skilled positions while low-skilled workers often migrate to informal sectors with lower wages and less stability. This is the policy question that no technology announcement resolves. Musk has spoken about a concept he calls universal high income, the idea that robot productivity could eventually generate enough surplus to support a broadly distributed economic baseline. The criticism of that vision is not that it is impossible in principle. The criticism is that there is currently no clear mechanism for how those productivity gains get distributed, and history suggests they do not distribute themselves automatically. The great agricultural transformation of the early 20th century created enormous economic growth. It also created the Dust Bowl migration, decades of rural poverty, and a generation of displaced workers who did not automatically find comfortable positions in the new industrial economy. Transformation and human cost are not mutually exclusive. Here is the question worth sitting with for a moment. Think about the industries where American workers are hardest to find right now: construction, agriculture, warehousing, long-haul trucking, physical manufacturing. These are not sectors that are struggling because people refuse to work. They are struggling because the work is hard, often physically punishing, frequently dangerous, and the demographic pipeline of workers willing to enter these fields is shrinking year by year. If humanoid robots become economically viable in those specific contexts, the disruption is not primarily to high-wage knowledge workers. It falls heaviest on the workers who currently hold those physically demanding positions. And those workers tend to have fewer alternative options, less capital to weather transitions, and less access to retraining. The productivity gain that looks like economic progress in aggregate statistics can look very different from the perspective of a 50-year-old warehouse worker in a mid-size American city. So here is the question worth leaving in the comments. If humanoid robots achieve even a fraction of their projected scale over the next decade, who in the American economy actually benefits, and who absorbs the cost of that transformation? Is this the tractor moment, where disruption ultimately generates broader prosperity? Or is it something the economy has never quite encountered before? Labor itself becoming a form of depreciating technology. The robot is not the story. It never was. The factory in Fremont is not the story. The engineering specifications are not the story. The story is a question that has sat at the center of every industrial revolution in human history. When the cost of doing work falls towards zero, what happens to the value of working? That question does not have a comfortable answer. It does not have a certain one. But it is the question that will define the next chapter of the American economy more than any election, any trade policy, or any corporate earnings report. What happens to work when work gets a competitor that never sleeps, never ages, never asks for benefits, and gets cheaper every single year? If you want to understand the forces reshaping the industries that drive this economy before they reshape your financial life, join us here. The story is just getting started.